All right, so here we go. So we got 13. 3 we're going to go over. Back in geometry, we had these sine, cosine, tangent things for right triangles. We had these special triangles, 30, 60, 90. You need to remember these two patterns. We're going to use them today to create or finish creating our unit circle. I told you we're going to come up with the coordinates for each of those angles. And we can do that because we know the radius is 1. And so we're going to create one of the quadrants, and then all the other quadrants follow right after the pattern that we already created. So we only have to do this little bit of math using this stuff and just refresher. So here we go. So if we are in the unit circle,
that dumb thing. Dumb thing.
all right, so if we are in the unit circle,
Gosh.
this thing is going to drive me nuts. All right, so try this again. We are on the unit circle. There we go. And we've got this right here is our coordinate plane. What is this ordered pair going to be right here? It's going to be 0, 0, the origin. What is this ordered pair going to be? 1, 0. Everybody understands that, right? We know it's 1 unit long because it's the unit circle. Well, let's talk about this one right here. Does everybody see? I'm going to try to do what I think is the easiest one first. If this is a 45-degree angle, and I draw straight down from that right there, what does that mean this angle right here has to be? 90 degrees, correct? What does that make this angle up here have to be then? So I've got a 45, 45, 90-degree triangle, correct? Now, this ordered pair, how in the world could I come up with this ordered pair? Well, how can I get that ordered pair? What is this right here? But isn't that how far I went over to the right, and then how far I go up? Correct? Isn't that the length of this leg right here on that triangle? And isn't this y going to be the length of this? So whatever this is, isn't that going to be my x coordinate for this ordered pair? And whatever this length is right here is going to be my y for this ordered pair up here. Do you get what I'm talking about? How far you go left or right, how far you go up is how you get an ordered pair, right? So I went right this far, and I go up this, that will be my ordered pair. Now I just got to figure out how long these legs are. With me. Well, the 45-45 triangle said this is x, this is x square roots of 2. So that means if I go from here, that's what's known. That is the special triangle. This is x units long also. This is x, this is x, this is square root of 2. X squared to 2. Well, how do I go from here to here? What do I do? How do I get from x squared to 2? What did I do? I multiplied by square root of 2. Well, the problem with our triangle is they don't give me the length of one of the legs. They give me the hypotenuse. So how do I go backwards to one of the legs? I have to take this to go backwards and divide by the square root of 2. Does that make sense? Well, when I do that, I end up with 1 over the square root of 2. What's the problem there? So to rationalize it, I times by square root of 2 over square root of 2, because that's really the number 1, but that cancels the bottom out, so I end up with square root of 2 over 2. Does that make sense? So the x for this is square root of 2 over 2. That's the length of this leg. What is the length of this leg? How high up? Look, it says it's x and x, right? So both of these are the same. So this is square root of 2 over 2, and this one is also square root of 2 over 2. Those are the ordered pairs for my unit circle for 45 degrees. Does that make sense so far? Good? We have one more triangle we need to do. Just go ahead and add the page. Yes. We're going to get there. Yes. You are absolutely on track. Let me get there. And if you would write stuff down, oh my gosh. So what are my other special ones that we've done on the unit circle? 30, right? We did 30 degrees. Well, if this is 30 degrees, what is that? And I go straight down. This has to be 90. What does that mean this guy has to be? So remember our 30, 60, 90 triangle. 30, 60, 90 triangle. The 30, 60, 90 triangle said this was x. Across from the 30 is always I call this the key. I call it the key because that's the one that I want all the other ones. Like, if this is x, this is 2x. If this is x, this is square root of 3 times x. Or x squared to 3. Actually, I like that better. The book writes it the other way. I like it like this. X square roots of 3. So if I have this one, I can find the other two really easily. Well, the problem again is, in this one, I know this length is 1. So what do I need to go back to first? Can I go from 2x to x squared to 3 very easily? No. So what do I go back to first? Yeah. So to go this way, I multiply by 2. Correct? So to go backwards, so I'm going to take 1 and divide it by 2, and I realize that this length right here is a 1/2. Does that make sense? Well, think about this for my ordered pair. What is that going to be? This is my, how far I go to the right is my what? X. Did I find that yet? No, I found out how much I went up. So what's my y for this one? Are you guys following me? About where this, again, do you remember these ordered pairs that you just saw, square root of 2 over 2? First day I walked in the trig, I see this number and I'm going, where'd that number come from? I thought she made them up, right? She never talked about this kind of connection, about how it goes back to the triangle, and you can recreate this if you had to. But do you see how long it's taking me to recreate it? What's going to be best for me to do? Do I need the unit circle for my test?
Yes.
Should I take the hour it's going to take to recreate this triangle, or this unit circle?
Yes.
What should I do? You need to memorize it. Now, if you forget one of the parts, you can use this concept to maybe help figure out one of them. But you shouldn't use this way to create the unit circle every single time. It will take you too long. I'm explaining to you where it comes from so you have an idea, so you don't have to just trust me, because I know you guys don't. So you can just be like, oh, he does make sense, like he's not making it up. But from now on, you do need to memorize this. And I'm going to show you an easy way to memorize these ordered pairs in just a minute. Okay? So last thing, if this is a half, how do I get to over here? What did I have to do?
Multiply by.
So I just take half and multiply it by square root of 3, which if I multiply fractions, top times top, bottom times bottom, I end up with square root of 3 over 2. So this is square root of 3 over 2. Do you remember me saying that's the last triangle we have to do?
Yeah.
Why? Let's look at our other triangle. What's our other angle that we go up at?
45.
We already did 45. What's the one we're missing? The 60 degrees. Now, if this is 60 degrees and this is 90, what does that make this? So, will that change the lengths of any of my triangle? No. This is now going to be across from the 30, which across from the 30 is still going to be a half. So my x now is going to be my half instead of my y. And my y is going to be square root of 3 over 2. Because all I've done is I've taken and rotated this same exact triangle. Does that make sense? So this is going to be, my x is now going to be this, a half. my y is now going to be square root of 3 over 2. It's the same length. I've just taken, here's my 30, and that was half. Well, here's my 30, and now here's my half, which is my x. You guys get what I just did? Yes? Okay. You want an easy way to remember this thing now?
Yes.
Okay. Here's an easy way. Now that we understand the concept, here's an easy way. Man, my circles are just getting better and better. 30.
Wait.
You're good. 40. And 60. Here's what happens. All you have to do is watch this pattern. 1, 2, 3. 1, 2, 3. Over 2, over 2, over 2, over 2, over 2, over 2. You can throw commas in there if you want. And then the last thing is to square root all the tops. Well, what's the square root of 1? So do I have to put a square root over it? No. Square root, square root. Do I have to square root that one? Because the square root of 1 is just 1. Square root, square root. Is that exactly what we got when we did those ordered pairs? So did everybody see what I did? 1, 2, 3. 1, 2, 3. All over 2. Square root all the tops. That's a quick way to help you memorize this unit circle because you do need to write this down quickly on your test. You need to be able to complete this unit circle out in less than 5 minutes. The only reason it should take you 5 minutes maybe is because of the writing time. You should not be thinking, wow, what was this? It's got to be quicker than that, or you won't pass the test. You won't have time. Now, what Chris was saying, which was very, very smart, which is never doubt. What Chris said is, wait, Mr. Mark, if this is a 30, 60, 90 triangle, when you go here, it's still a what? In fact, your x is still going to be the same distance. Your y is still going to be the same distance. The only thing that changes, instead of going to the right, I'm going to be going to the left. What is that only going to change in my ordered pair? It changes the x to a negative, but the y still stays. So what would this ordered pair over here be? Negative square root of 3 over 2, 1/2. What is this ordered pair going to be? Negative square root of 2 over 2, comma, square root of 2 over 2. So notice, all I'm doing to these guys right here is I'm making the x negative and keeping the y positive. Notice the lowest one is going to match up with the lowest, meaning the x and the y are the same numbers. The middle one is going to match up with the middle one, and the highest one is going to match up with the highest one. And all you got to do is change the negative. Yes. The same thing in the quadrant. So down here, what's this quadrant? What are my x's all? Negative. What are all my y's? So all I'm going to do to this ordered pair, right here, or this one, doesn't matter, is I know it's going to be the same numbers, except it's going to be a negative square root of 3 over 2 and a negative 1/2. Does that make sense? And then over here, it's going to be a positive square root of 3 over 2 and a negative 1/2. And then you can fill out this unit circle with the rest of those ordered pairs. So that's why I said all you have to do is memorize this side over here, and then you can mock it over here, and over there. How are we doing?
Can we still use the little trick thing of words like 1 to 3?
Whatever you need to do.
Still use it for the ones.
Whatever you want to do. So it would still be 1, 2, 3, 1, 2, 3. Be careful. 1, 2, 3, 1, 2, 3.
All over 2.
Yep. And then this one, Both would be negative. Yep. And then this one, only your x would be negative. This one, only your y would be negative. Now, last thing. I want to go over real quick. You remember, any right triangle, you had this thing called SOA. Correct? Well, if it's on my unit circle, which this is terrible, but shut up. Okay? This is on my unit circle. I don't even know. It's a little lopsided. So this guy right here, hold on. If this is my central angle, does everybody understand that? This is my central angle. This is my x, and this is my y for my coordinates up here, correct? This is x. This is y. You guys with me? And this is for my unit circle, it's 1. Correct? Because the radius is 1. What is sine of this angle? What is sine of theta really equal to? It's equal to opposite. What is the opposite?
Y.
Over what? So what is really sine of theta really equal to? The y coordinate of that ordered pair. You following me? What is cosine really of theta really equal to? Adjacent, which is
X.
x over,
1.
which is just,
X.
and tangent of theta is really opposite y over x. So let's go back. Hold on. Let's go back to this one. What is the sine of 30 degrees? The sine of 30 degrees is really just the y coordinate. So if I asked you for the sine of 30 degrees, it equals 1/2. The sine is always your y coordinate. Do you guys get what I just said there? Your cosine is always going to be your x coordinate. And your tangent is always going to be your y coordinate over your x coordinate. Here?
Yeah.
No. Oh, opposite over hypotenuse.
Oh, okay.
Opposite, which is the
Oh,
opposite
over
side
adjacent.
over that. Opposite over adjacent, and SOHCAHTOA thing. What do we think? Make sense?